here's a situation. They can tell you that a die is being rolled, and then they can ask you what is the probability of it being a 1 or a 6. So what is the probability of it being a 1 or 6? So whenever you see whenever you see them saying what is the probability of this or this, you have to use what we call the addition rule. So you have to memorize this thing. So it's probability of A. This also comes in the formula sheet. So it's the probability of A or B, which is equals to the probability of A plus probability of B minus the probability of both of them happening at the same time. So it's probability of A and B. So you have to cram this formula. So we have the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. So what is the probability of getting a 1 or a 6? The probability of getting a 1 or a 6 is the same as the probability of getting a 1 on a dice, right? Plus the probability of getting a 6 minus the probability of getting a 1 and a 6 at the same time. So what is the probability of getting a 1? Well, 1 over 6. Probability of getting 6, 1 over 6. There's only 1 6 on a die. The probability of them happening both at the same time, it's impossible, right? You can't throw a die and get a 1 and a 6 at the same time. So they can't happen at the same time. So it's a 0. So hence the probability is gonna be 1/3. So that's gonna be the answer when we add this stuff. So as you saw that 1 and 6 cannot happen at the same time. So we say they are mutually exclusive. So this word is very important. Whenever two things cannot happen at the same time, we say they're mutually exclusive. Mutually just means what you do to me, I do to you, right? We do it mutually, right? And then exclusive. So we've just cancelled what we said before. So it can happen at the same time. All right. So there's what you call complementary. So this is what you call complementary events. For two events to be complementary, these things that I just put now, they're not so basic that they don't appear. They do appear in the exams, right? So complementary events are events that are mutually exclusive. So for something to be complementary, it has to be mutually exclusive. And number 2, it has to be exhaustive. So we say two events are exhaustive if when we add them it gives you 1, right? So if I say probability of A plus probability of B so if I say probability of A plus B is 1, so it's like they use up the whole sample space, like heads and tails, for instance. Heads and tails use up the whole sample space. There's no other possibilities except for those two. So probabilities of heads plus probabilities of tails is 1, right? Because half plus half is 1. So they are exhaustive. So for two events to be complementary, they must be, number 1, mutually exclusive. Number 2, they must be exhaustive. If they fail one of these, then they're not complementary. So let's look at the situation. Let's say we're given the set of numbers, and then they ask us, is choosing an even number and choosing a prime number complementary? So is choosing an even number and choosing a prime number complementary? Okay, so even in the exam, this is how you answer it, right? So if you want to check if choosing an even number and choosing a prime number is complementary, or if you want to check if two events are complementary, you just have to check if they're mutually exclusive. We checked if they were mutually exclusive, they could not happen at the same time. Then we had to check if they are exhaustive. So for them to be exhaustive, they have to add up to 1, their probabilities, right? So the probability of choosing an even number, we had 3 over 6, which was 1 over 2. The probability of choosing a prime number, we had 3 over 6, which was 1 over 2 also. And then when we add the probabilities, it was 1. So they were also exhaustive. They also fulfilled exhaustive. That's why they're complementary. So we can say, therefore, those two events are complementary. And then the other thing that you have to memorize is the product rule. What is the product rule? So when we say two events are independent, for independent events, so when two events are independent, the probability of getting A and B is the same as the probability of A times the probability of B. So when two events are independent, the probability of A and B is equal to the probability of A times the probability of B. So in an exam, they can just tell you that the probability of getting A and B is equals to, let's say, 1 over 4. And the probability of getting A is 2 over 5. Then they can ask you, what is the probability of B? So what you do, you just use this equation, you see. When they tell you that this is independence, they can tell you that two events are independent and the probability of getting A and B is this, the probability of getting A is this, the probability of getting B. They ask you, right? So what do? You just substitute into that equation. So the probability of getting A and B is 1 over 4. The probability of getting A is 2 over 5. The probability of getting B, we do not know it is yet. So from there, you know what to do. I can just multiply here by 5 over 2 to get rid of this thing. So I'm just going to use this method. So then the 5 will cancel that 5, the 2 will cancel that 2. Then I'll be left with probability of B is equals to, this is going to be 5 over 20. Right? Many methods you could have used here. You could have also just said, okay, fine, let's just divide both sides. You could have just said, you could have also said 2 over 5. You divide by 2 over 5. Divide by 2 over 5. But remember with this, you must be careful. In the calculator, it's better to type it like this. Right? Type it this way in the calculator. If you try and type it this way in the calculator, you might get it wrong because maybe in the calculator, this line might be the longest when it's not supposed to be. All right. So